Hello, welcome back to UGC-NET Exam Prep. In this lecture, we are going to cover Unit 5 of Business Statistics and we are going to cover measures of central tendency, that is mean. Okay, so, right. Now, there are two types of arithmetic mean. First is simple arithmetic mean and the second one is weighted arithmetic mean. Now, what is the meaning of simple arithmetic mean? Simple arithmetic mean is the average of the set of values which is calculated by adding all the values together and then dividing by the number of values. So, formula of simple arithmetic mean is sum of x by n. Now, suppose the marks of 5 students in a class is 60, then 70, 80, 90 and 100. Right. Now, how we are going to calculate the average mean? This is going to be divided by the number of items. So, the number of item is 5. So, our answer will be 80. So, this is simple arithmetic mean. Now, second one is weighted arithmetic mean. Now, weighted average arithmetic mean is the average of the set of values, that is considering the importance, that is the weight which is being assigned to each of the values or the items. So the formula for weighted arithmetic mean is sum of weight of each of the values of the items multiplied by the individual items divided by individual weights, or we can say the total weights. So if in an exam marks of the students are 60, then 70 and 80, and respective weights that is being assigned is 2, 3 and 5. Okay, these are the weights. Now how this is to be calculated? Now 60 will be multiplied by 2, then 70 is going to be multiplied by 3, and then 80 is going to be multiplied by 5 divided by total of these weights. So 5, 6, 7, 8 and 10. So our answer will be 74. Right. So this is weighted arithmetic mean. Now here is the features of simple arithmetic mean. Arithmetic mean is the most commonly used average or measure of the central tendency. This is even known as mean, and the definition of mean is being provided over here. This can be used in ungrouped data as well as in group data, like the data which is arranged in the tabular format, where the grouping of 0 to 5 or 10 to 15, this is being done, or this could be done in case of ungrouped data, like we have seen in the previous slide, the marks of the students or the income of the consumers and all. So that can be calculated. Now next we are going to look at the pros and cons of arithmetic mean. Now MCQ questions are being asked often from all these pros and cons of the various means, or we can say the central tendency. Questions are being framed according to that. So what are the pros? So firstly, it is rigidly defined. The arithmetic mean is always specifically designed. It has a certain numerical value. Right. Next is it is easy to calculate and it is very much simple to follow, because weighted average mean is even simple and arithmetic mean both is simple to calculate, as we have seen. It is based on all the observations. So one of the observations should not be missing out. There should be presence of all the observations or all the items, then only the arithmetic mean could be calculated. Next is, it is determined for almost every kind of data. So ungrouped data, group data, raw data, so in every sort of data this arithmetic mean can be calculated. Next is, it is finite and it is not indefinite. So the arithmetic mean always has a specific numerical value. It is not a vague or it is not indefinite. Even if the data is going to consider or take into consideration the larger or the smaller number, the smaller items, the figures. For example, suppose the values are 10, 20 and 30. Right. Now, how the mean is going to be calculated over here? The mean is 10 plus 20 plus 30 divided by 3. So, there we are going to get a specific number, that is 20. So this is a definite value which we are getting after all the calculation. There is no vague over here. Right. Now, next pro is, it is readily used in algebraic sort of treatment. So the mean can be easily used in algebraic formulas and for calculation of mathematical operations. It helps in solving out the equations, for finding complex deviations, for calculation multiplication, divisions, and for comparing groups of data. For example, if the mean of 5 number is 60, right, the mean of 5 numbers we are getting as 60. Now what will be the total sum? That is simple, 60 into 5, right, 300. This is how the arithmetic mean is readily available for further algebraic calculations, for further algebraic treatments, right. The last pros is, it is least affected by fluctuations of sampling. So when we take different random samples from the same population, then the mean of these samples is not going to change that much. It is going to remain at that population mean only. For example, if population marks of the students is 50, first let me erase this one. Wait a second, okay. Yes. Now, if the population marks of the students are 50, then 60, 70, 80, 90. Right. Now, what is the mean that we are going to get over here? All from 50 up till 90 we are going to add, then we are going to divide by 5. So the mean over here will be 70. Now, if we are going to take two random samples, suppose one is 60, 70 and 80. 60, 70 and 80. And then we are going to take 50, 70 and 90. Now what the mean we are going to get? 70 and 70. Okay, we are going to get equal sort of means. So both the samples is going to give the same amount of mean, and this is going to show that there is less sort of fluctuation. It is not affected by fluctuations of the sampling, or it is least affected. The mean is going to be equal, right? All these are the pros. Now let us look at the cons of the arithmetic mean. Now the arithmetic mean is highly affected by the extreme values. Now if the values are suppose 10 and then 15 then 90, then what is the mean which we are going to get over here? 38.33. So now this is not a true representation of this whole group of set, because 90 is the extreme value over here and it is dragging the data. Next is, it cannot average the ratios and the percentages properly. Now what is the meaning of that? Mean of percentages or ratios may give misleading results if the base values are completely different. For example, if 50% of 10, if one equation is this and next equation is 80% of 100. So if we are going to solve out this, so 50% of 10 we are going to get as 5 and 80% of 100 we are going to right 80% of 100 we are going to get 80. Now when the base values of percentages are not same, we are going to take a simple average of the percentage and that is going to give us a wrong impression. So in group A we have seen that 5 students have only passed, and in group B we have seen that 80 students have passed. Now if we are going to calculate the average of these percentages or the mean, we are going to get 65%. Right. So this suggests that 65% of the students have passed in overall. Now, if we are going to do this calculation in the weighted average method, if we are going to employ weighted average method over here, so total passed over here we are getting 80 plus 5, that is 85, and the total number of students over here is 10 in group A and 100 in group B. So total over here is 110. Right, and then we are going to multiply it by 100. So the answer over here will be 77.27%. Now this is the real average which we are going to get through weighted arithmetic mean. So this is the reason that averages, it cannot average the ratios and the percentages properly if the base values are different. Right? We have looked upon this in depth. Now the third con over here is, it is not an appropriate average for highly skewed sort of distribution. Now, what is a skewed distribution? A skewed distribution means that the data is not sort of balanced. Right? It is not balanced. The right tail and the left tail is not balanced. Either it is going to be positively skewed or it is going to be negatively skewed. So this means that either it has a very high or very low values that pull the average in one direction only. So averages will, in the positively skewed data, in the right side all the averages is going to be gathered, and in the negative skewed data all the averages is going to be gathered in the towards the left side. So this means that the mean is very much sensitive to the extreme values. If a few values are too large or too small, they are going to distort the whole average. So the mean may not represent the actual value of the data. Now suppose we are going to see that the marks of 5 students in a class test. So the marks is 2, 3, 4, 5 and 100. So once we are going to calculate the mean, again we are going to calculate the mean over here. So what we are going to get, right, after calculation of the mean, we are going to get answer as 22.8. 114 divided by the values or the items. So the mean over here is 22.8, but it is not representing the value, right? Because 22.8 is closer to 2, 3, 4 and 5, and it even shows that 4 out of 5 student has scored less than 6 or 7 marks, and only one person has got this 100 marks. So it is not a better representation. So it is not an appropriate average for highly skewed sort of distribution. There should always remain a balance over here. If the 100 has to be replaced by other numbers like 8 or 9, then the mean would have been appropriate, right? Now the next point over here is it cannot be computed accurately if any sort of data is missing. Yes, if any sort of data is missing, the answer we are not getting that right. The last point over here is that the mean sometimes does not coincide with any of the observed values. So this means that the mean might not match any data point in the set. Now suppose the data which we are getting is, or which we have to calculate, is 1, 2 and 3, right? Now the mean over here would be what? 6 divided by 3. So 2 is our mean. And if the data is 1 and 3, now how the mean will be calculated? 4 divided by 2, then 2. But 2, we are not getting any sort of data, that is 2, in our data set. In the data set we are only having 1 and 3. So it does not represent the data. The mean sometimes does not coincide with any of the observed value in the data set, right? So this was all about today's lecture. We have looked into all the pros and cons of arithmetic mean in detail. So any of the questions which will appear in the exam, I hope you will be able to solve it. In the next lecture, we are going to cover the problems related to the arithmetic mean. We are going to cover the individual series, the discrete and the continuous series. So if you are having any sort of questions regarding any of the topics which is being explained during the lectures, you are free to ask your questions. I would love to help you all. So thank you, and let us meet in the next lecture very soon. Okay.